Hello everyone and welcome to another episode of No Orientation Programming. I'm Joe and today we will work on our simulation architecture of the ESP32 audio processing project. We have created last time a documentation. Let's see, is this better? Yep. So this is the structure of our simulation environment. On the PC side, we will have a signal generator, and we send this thing to the ESP32. We can compile this code, this software for PC and for ESP32, and essentially we have three parts of the software. That is the PC related parts, the hardware related parts, and the stuff in between, which we need for both cases. Actually, this PC related part will also be available in both cases, because we will be able to, we want this thing to be able, the ESP32 to be able to interact with the PC as well, not just the simulation environment. So let's see, we could blend to ML live, blend tech. I think that we should make this rectangle dashed, if it's possible. Blend UML component component diagrams. Is it possible? Here we can at least we can have dashed lines for the errors and the connections, but I'm not sure if this is possible for, we can have a different color for the boxes, but hopefully yes. Dashed. Yes, let's see. Hardware modules. How would this look like? Listen cell buff out to send. Ah, damn it, not the right one. Buff out to serializer. Yes, that's it, I guess. Yes, so this path is not available in every case. But actually I would like to make the box dashed. I think that's not possible. Yeah. Okay, okay. Should we keep it that way? I don't know. Generator to listening. No, that's the stuff above. So this part is optional. Yes, I think that's okay. So, okay, that's fine. So, undock update simulating. Okay, processing components. What? Okay, okay. Remove. Fine. Yeah. Cool. Okay. Fine. So, document system. Fine. Okay. So, the next step is to implement every rectangle. But at first, I think we have to implement here. For this rectangle, we need a Python thing, I guess. So let's see what we have. Home. Tools, no, source. Python physics exercises. Hello, banana bear. How are you? Convolution chapter. Yes, let's Python physics. Let's check this out. What's up? Okay, what do we have? Oh, Cractorio. Is it Cractorio? Okay, yes, that's Deep Rock Galactic. What's that? Deep Rock Galactic. Okay, interesting. And cool. That's that a strategy game. We have the Python physics. Okay, so Python. And then we have streaming, ECAT, transmission lines. RF switch, no, tools, pulse signal, OST data sheets. Oh yeah, oh come on, now this structure is so crazy. No, it's good. No, you were looking at the survival version, being an idle game where you just run around and select perks weapon. I'm playing the first person thing. Oh, okay, there are two. Deep Rock Galactic FPS. Ah, okay, so this one. Wow, looks fancy. That looks quite cool. Mm-hmm. Mm-hmm. Nice. Oh, cool. I have to check this out someday. Looks kinda nice actually. So what do we have here? Recall. Yeah, so this is some fancy stuff, but somewhere we should have. I have to find case insensitive name Python. Yes, that's the animation stuff. Okay, so now I'm finished. Oh, Spring Sale, 10 euro. Oh, should I buy another game I will not play? Maybe. Okay, so we have this is fine. Okay. So initialize and then process. Okay. PyAnimating. What is PyAnimating? PyAnimating is a class which has an init function, then a user interface base create, slider add, tree tick. Okay, so how is this working? Okay, success pending, tree tick. What? Where is the sleep? There must be a sleep somewhere. P application is direct animating, while success is pending, tree tick. Okay, I guess today is the day where we should implement the Python version, but I'm not sure. Do we want to code the Python version of the processing class? I don't know. Oi, oi, oi. Oh. Yes, okay. Okay, so okay. Audio processing. So we have simulation. Oh, hi Nick, was it? How are you? So today I'm not sure if we should do what we have to do, because last time we have created an overview of the simulation environment of our audio processing project, and we have, yeah, and the cool thing is, with our cool structure, the GitHub. So with this thing, we have a lot of advantages during development. One advantage is we can create stuff like this, and diagrams which are process based. So we have essentially rectangles which are taking something as input and then producing some output. And the cool thing is, if we have an overview like that, then we can estimate how long it takes to finish the project approximately. At least we can say what we still have to do and on what we have to work. So here we see we have to create the filtering process, selecting process, something that is listening on samples on this side, and then we can go from rectangle to rectangle and implement the stuff, and then more and more is working. So that's cool. And that's fine, but today in this area we do not want to code in C++, but in Python, because in Python we have a cool or maybe as you can see we have yes, neck force, so that's it. So this is that's a cool surface in which we can do a lot of cool animation stuff, and this is actually quite a cool environment, and it's based on a Python Qt6 thing. Is can we create the same? Can we create the same thing? This surface with a C++ implementation. If that's possible, then this would be much better. Because actually I don't want to code in Python. I want this thing to be in C++. Let's check it out. C++ Qt6 Surf UI example. Main. we have a Q application, we have a Q widget, UI setup UI widget show. What should we do here? What are we doing here? We have a self UI base create. Okay, UI base create is the function in which we create a box layout, a grid layout. We make a fancy Matplotlib binding stuff. So we create a user interface which has this structure. On the left side we have regulators, and on the right side we have a blank screen essentially, and here we bind the Matplotlib output. And then we can add a slider. Okay, fine. Labels update. Boah. This would be quite cool if we manage to create the same thing in C++. This would be quite cool. Is there some library we can install? Let's check this out. We would save a lot of time. We would save a lot of time if we can create this in C++. apt cache search Qt. Qt5. Python stuff. Okay, Python 3 bindings for Qt5. For beginners, yes. I don't want to create a Qt application, and I don't want to use the Qt creator. I just want to use the best IDE ever made. That is the VI editor. Q application app exec. The app exec is you will not see a Rust stream here, Kuchenmann. I had enough Rust for today. How are you doing? I'm not sure if we should work on the Python application or if we should make, yes, the C++, a C++ user interacting. Qt user interacting. Let's create a Qt user interacting. Process in C++. I think that's the best approach. Okay, that's here. C++ process. Let's create a Qt project seems a good idea, and yeah, it's quite cool. I've created Kuchmann. I guess you don't know it, but we are using in every project, in every file, we are using this base class. This C++ class is the base of every project we use, and it's essentially a recursive structure. And in this structure we always have just one simple function, and this function is called process. And in the process function we always have a switch statement, and in this switch statement we have commands, and then we go step by step through each process. So this base class is finished for the C++, but it's not finished for Python, and I don't know if I want to create it in Python, because actually I don't use Python. So although it's a cool language, but somehow I would like to keep to stay in C++, but my problem is that I don't know how to create a Qt application hello world. I want the same thing for C++, the same surface. Okay. Maybe we find a cool tutorial, but let's just first create a new process. And this process, so we need a completely new application, completely new application in our audio processing. Directory. Let's call it simulation main. I don't know. And then should we create a new Git repository for the simulation? I think in Qt you can create a window class with hello world. Yes, but I don't want to use the Qt creator. Qt core. I just want to install some library and then just use the library, and then I want to make a window. Without Qt or Qt creator? Sure, you can, although it's more convenient with Qt and CMake. Qt libraries, Qt core and Qt GUI. Hello world. Import. What import? In QML. No QML. No QML. Yes and no QML. I think this looks kind of promising. Qt core, my proxy pp. Do we have a code for a Qt empty libs ld flags? Yes, Kuchmann, I know it's we are picky. We are picky. So, but I think that should work. So we just have to install the core in the GUI library. Let's install the core in the GUI library. And do we have a Qt core? Qt core or 5 core Qt5 core module and GUI module. What's the A? OpenGL variant. I think we should install these two. Should we use this version 6? Yes, why not? Should we use this version 6 one? libqt6 GUI 6. Is already in the newest version. Oh, perfect. Okay. So we in the processing common library we create a new class, and this class should be Qt simulate Qt animating. Qt animating. Let's call it Qt animating. Whatever. So, and in the audio processing, yes, let's just create a new project in this repository. Mason build. We have, let's call this simulation main. Audio processing simul AP ESP32 nope ESP AP nope. Naming is the hardest part. Naming is the hardest part of programming. So someone said two things are the hardest part in software development. That is cache invalidation and naming things. How do I want to call this application? I don't know, just simulating. Mason build, then we say main. In Mason build, project ESP visualizer. Yep, ESP visualizing. So that's a process. Perfect. Can we do this? Oh, nice. Cool, fancy. So we have a main, and the main is the same like anywhere. So main, if not defined, yes, let's just keep that. If not defined, so simulating, okay. App supervising, fine. Then That's the same. If not defined, that's app main. App main, we don't need app main here. Let's just copy the content from here to here. Oh, looks fine. Okay, so extensor, if not defined. If not defined. Oh, looks good. Okay, so the main file is always the same. We have an include of our app supervising process. We have a handle for the SIG interrupt and SIG termination. As always, we create a process, we check the process, then we have this while loop. We tick the tree, sleep for 2 milliseconds, and then break if we do not have a progress. Then we destroy the application and close the application. Yeah, the naming. Okay, could be better at this part, but we have app supervising. We can just copy this one. Okay, we do not have an extensor here. We do not have this here. So debug start. So that file should be fine. Then we can copy this one. So we do not have Wi-Fi connecting. We do not have this stuff main start. Yes, let's keep main start. Extensor main start. We do not have Wi-Fi start. We just have main start. We jump from start to main start, or just, yeah, we do not need main start as well. So just start and then here, yeah, fine, wonderful. Okay, so we have a proc state, that's fine. So we do not have extensor here. Let's search for extensor. I think it's fine. Debug start, application start. Okay, so the application start is we need another process. CPP processing is simulate. No, let's call it in this case visualizing. CPP process visualizing. Okay. So the application is actually called not audio processing but visualizing. Let's call it CPP rename visualizing but ESP visualizing. Okay, so this is now the main file. Okay. ESP visualizing, fine. So then we have to build this thing. We have a lot of warnings activated. We call this project ESP32 ESP visualizing. Dependency threads have log buffer size GNU 11. Host machine system Windows. Okay, yeah, why not? We can create we should be able to create the simulation software in Windows 2. This is the part in the core, libtime thread pooling. Yeah, why not? Main. Then we have main ESP visualizing directories, core and common. Oh no, we need yes, that's Mason will complain. We go out 1 and we go out 2. I guess Mason will complain. But let's see. Because the components are now outside of the root directory. Yeah, let's see. Mason setup build native. Okay, no such file because ESP visualize. Oh fuck. Include visu. ESP visualizing. Okay, debug start not declared used because I have deleted this. I have deleted these two functions, and if I delete the functions, then the compiler will complain, of course. Okay, so a debug start app start. Here, fine. Okay. Return statement with no value in int main. Yes, that makes sense. Return Vim is self-torture. No, Vim is the best IDE which was ever made. So, it's linking, that's fine. So let's try to execute the application. So now we have, as always, we have 3 channels now. The first channel is the log. Then we try to, that's the process of our ESP32. That's the log. And that's the command interface of the ESP32. And now we try to connect to the local application. Nets.ntl. So we have these 3 channels who love life, and there are people who love Vim. So, that's the command interface of our application. So this is perfect. Telnet localhost 3000, and that's ESP visualizing the application. So the hello world is done. Telnet localhost 3001. Help. Okay, yeah, fine. Nice. So the system is running. If we press Control C at this point, then, and that's the cool thing, the whole application is shut down in a clean way, and every connection is closed. Okay, fine. So that's our simulation base. Now we have, this is I'm a JetBrain idea abuser. I've never worked with JetBrains or C-Lion or anything else. I just used Visual Studio at the beginning. I used Visual Studio 6. The very, very old one, and then I used Eclipse, and because Visual Studio had a feature creep and got bigger and bigger, and then I switched to Eclipse at a time where Eclipse was small and fast and cool, and then it got bigger and bigger, and then I switched to VI or Vim, and now I am happy. So that's all. So perfect. App supervising. In app supervising, we just have to start IntelliJ and Sea Lion and monsters. Actually, I kind of like Visual Studio Code. It's lightweight, and I think it's quite cool. It's nice. So in the app supervising root process, we just have to create the debugging process and the application main process. And in the application main process, we want to start our Qt animating process. So let's start this process like yes, we need a pointer to it, I guess. So we say Qt animating, and we have a pointer to it that is called mp Qt or anim. We initialize the pointer, of course. Perfect. So then let's check if and then we want to say mState is equal to state main, and here we want to create the process. Anim is equal to Qt animating create. If not mp animation, then proc error log -1 could not create process. But return, of course. But if we were able to create, so we check the error, of course, the result of the creation, and then we say start mp animation, like anywhere, like every time we just create, check and start, and then this thing should be running. Yes, we should give Mason the possibility to compile this thing. So we have a thread pooling. We could start a thread pool as well. Qt animating. Let's start the thread pool as well. So processing pointer p process, and let's create a thread pool. P process is equal to thread pooling create. If not p proc, yes. And then we have to start the thread pool, and we should see the thread pool now, hopefully. Animating your thread pooling. Oh yeah, perfect. Linked and starting. Oh yeah, let's say ninja and app. Come on. So no workers configured. Yeah, fine. So we didn't configure workers, but this thing want to. Yeah, then let's say p thread. And here we say p thread worker count set. Let's say 3 workers. Okay, now it's initialized and it's happy. So now let's check the tree again. Now we have 2 more processes running. The thread pooling process, which created 3 worker threads, and the Qt animating process is waiting to be implemented. Okay, so fine. Here we can register commands for the application. Okay, fine. Oh, nice. So now it's we will have the interesting part, because we have to implement the Q animating process. This Qt animating process should do the same like literature, Python animating, like this thing. I want to hard code the layout in the CPP file. I don't want to have an additional file. I just want to keep it as simple as possible. And this thing should just have a surface like this. It should be divided into two parts, a big picture screen, and then here we want to have regulators. Nothing more. But we need QML use XML, I think. Yeah. Ooh, but we need two things. We have to we need this this thing is dependent on two things. This process is dependent on the Matplotlib and the Qt Python Qt5. Oh my god, holy moly. Oh, okay, so it's not Qt animating, it's a Phi animating. Is this even physics? Yeah, spelled correctly. Okay. So we should rename this thing. Components, common. CPP rename Qt to Phi animating. Okay, so here we have Phi. Okay, fine. So let's compile. No such file. That makes sense. Qt Phi. Nice. Okay. So because this Phi animating process, physics animating, is dependent on two things, Qt and Matplotlib. And I hope Matplotlib is available for dependencies Qt6 and Matplotlib. So hopefully there is a Matplotlib for apt cache search Matplotlib. No, Matplotlib is just a Python library, I guess. Matplotlib for C++, for Python's a C++ wrapper for Python's Matplotlib plotting library. Of MPL to C++. Should we use this? Pip install includes and linking. Maybe we should. Is there some liboctave or something like that? Matplotlib. Now I know why I created this thing. Can OpenCV plot stuff? Yeah. Yes, yes, OpenCV. However, this may be useful for people like me who shifted from MATLAB or some well-developed scientific tool to primitive programming. Plotting is a little bit tricky. Job in C++, as there is no default plotting library available. There are many libraries available. We will make a plot pplot. Yes. Plot stuff. Yeah. Okay, let's check OpenCV. OpenCV. Plot histogram, for example. OpenCV, find, plot, analyze. So this surface of fire animating has two parts. One part is the widgets which are provided through Qt. The function to be able to grab this thing and move it around. That's the widget stuff coming from Qt. And this part is provided by Matplotlib. CV plot. What? OpenCV. OpenCV is using creating plotting histograms. Short way, use Matplotlib. Long way, use CV drawing functions. Actually would like to go the short way. Matplotlib, yeah, whatever. No, let's try to make use Matplotlib for C++. Because the migration we can exchange, we can replace Matplotlib later, but at first we should use this thing because we have we have the complete code we can reuse or check. So I think that's a good base. So then we need fire animating Matplotlib. Yeah. Okay. So what should we section compiling or explains the compilation of one using the matplotlib header. Okay, compiling a program. I think at first we should focus on the Qt part, because at first we have to create the base structure with the regulators. Okay, so okay. So getting started with Qt widgets. So we have to check first how to include the core, the Qt core and stuff. That's plotting package. Nope. That's path Qt What's Qt for Qt3? Okay, or libs Qt core. Okay, let's check. In Mason, we have to add this thing to our dependencies. So we have a dependencies plus equal dependency Qt6 Qt core. Let's see if this is working. Okay, dependent not found. Right, package config and cmake. Yes, because we apt cache search Qt6 core 6 lib Qt6 core 6. So we have to convince Mason that this package config is available. Use a lib package config. Yes, find a name Qt6 core. Okay, in Linux GNU, Linux, what, where, user lib, x, package, we should have a package config too, okay, fine, and here we have a Qt, damn it. Let's search find dot package config files. Okay, we have a lot of package config files, and then we can search for what is this thing looking for. Tried package config and cmake. Lib Qt6 core. Mason dependency library. So set lib contained Qt charts. What's Qt charts? Yeah, that looks cool actually. If we can remove a dependency, this would be very, very great. if we can just use Qt6, this would be fine. Okay, so yeah, we have, I think that's a basic chart thing. Matplotlib has quite special functions. Okay, so but maybe Qt charts question mark. So pip3 install matplotlib. We have, I guess we have matplotlib already. And defaulting user document already satisfied. Deprecation with non-standard version number. Yeah, a new release of it is available. What the hell? Python blah 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 blah. Okay. Yeah, nice. Yeah, the install fine. Okay. Deprecation was non-standard version number. Will enforce this behavior change. A possible replacing the upgrade to a newer version of distro info. Okay. Pip install upgrade that stuff. Can we do this successfully? Oh, you're nice. Okay. Hopefully I'm not breaking anything important like many times before. Okay, so not compiling anymore. Nice. Okay. So complaining, not compiling. So okay. libcurl, libcrypto. These packages have a package config. That's nice. But we need the library itself. So how can we tell Mason that it should take a lib the get package config variable? No, package config dependency. I fully use external libraries, and Mason makes it very easy to find and use external. Here's how one should use zlib compression library. Zlib, and that's it. Dependency lib Qt6 core. Okay, maybe just static library. Ooh, yeah, let's check libcrypt dependency, libcrypt version. So it seems that we have to add the lib prefix. Not found. Did we use this in the gaming server? Dependency. Okay, libcurl, for example, and libcrypto. Yeah, these libraries have a package config. And they are found, of course. Threads found package config cmake. Libium found not thread cmake. Mason find library without package config. Get compiler find library. Oh no, nice. Steps plus equal stuff. Get compiler C++. Maybe this thing will help. To access compiler for not specified for host machine. C++ shared a static library, not, oh, okay, nice. Y. Link for the host machine, C++. Get compiler. Okay. Because you will be unable to use the headers. Maybe now I have to. Maybe I have to. Nope. Nah. Dependency. What I should use? Why isn't this working? Dependency required false. Get compiler C dependency. Not dependency found. Find library. Okay. Yeah, we used find library. Come on. Mason, find library. What is happening here? Okay. Compiler, find library. Okay. A lib name. The library to find. Oh, nice. But it's not finding the library. Oh, okay. For which system? X86 64. That's strange. That's strange. They say something about setting compiling the lib. Depending on Linux. I'm building an application. Which uses a framework on Ubuntu. When I try to use an apt-get, the Debian on build percent. Sure. Mainly because it provides the person in my application. So that's for deployment. But they should be able to link on my system. Why is this not working? Dependency foo required. What's that? Foo dependency. If not found, if package config is not available, try heuristically grabbing libs. Haha, interesting. Header of the lib has headers. So this has headers. You just cannot have it to be automatic fallback. Oh, that's cool. That's a cool example. That's a very cool example, because the dependency foo dependency gets overridden. That's cool. Okay. Yeah, let's try to find the header file. Find Qt core header. Oops. So do we have a header file somewhere? No, yes, no. Yeah, I understand. I think, yeah, because I think I understand. The devil pack, yeah. The devil pack. Cute. We have to install the development kit, of course. So let's say base 5 development. Base development files. I guess base development is fine. Hopefully. I think. Oh, let's just try it. Oh yeah. So Qt apt install base dev. So now we should have more stuff. Python, oh, Matplotlib, Python, stuff, okay, CMake, okay, what the hell, CMake, okay, maybe now we can just fine, runtime dependency Qt6 core found, fine. It's always better to just install it like that, because this is a fallback. This is a fallback if you have a library that is not state of the art and does not have a package config. The package config files on the system, which are installed on the Linux system, tell Mason what maybe there are multiple library files. So let's check this out. A package config file lib package config x60. Yep. And then we have package config, and now we should have core Qt. Do we have a Qt core file? We should have a package config and of the Qt core. Runtime daemon found, yes. Okay, maybe it's looking for the, no, it can't look for the, never mind, just let's check out a package config file of any library, Qt6 package configuration file, and here we see that we have a prefix, we have a lib directory, and this thing gives us the opportunity to automatically set the compiler flags that are needed. For example, the linker gets an L directive, which is setting the directory. The compiler can, so the linker finds this library at this place, and then -L include the libcrypto. So this package configuration file is somewhat the automatic compiler and linker configuration. So and that's quite convenient, because then we can just say we want this dependency. And this is similar but not as powerful as this approach. So perfect. Now we have Qt6 dependency met, and now we try to add the matplotlib dependency. So fine. So, and here we have to install this. Oh, we did already, I guess. Include and linking. So, dangerous. Shouldn't be executed in. So requirements satisfy multiple in user lib python dist packages. So user lib dist packages. What? Python 3 dist packages matplotlib. Yep. Okay. Okay. Include the header depends on the Python header. The content Python library lib Python and the Python header comes with Linux user local Python. The Python library. The program has to be linked against the compiled Python library. Okay, depending on the Python version, the name differs depending is this. Okay. So what should we add? We just want to have Python. You could not find an exact match. Mason found the following partial matches. Python interpreter using imported less using imported is recommended. Dependency modules okay. Partial matches. Dependency modules both. Mason will not continue to use the old style Python library CMake variables to extract. Okay, let's check Mason at lib Python. Python dependency. Python interpreter. Do we want a Python interpreter? I don't think so. Okay, let's see. User lib. What is Mason never seen used? Mason is a very cool thing. It's like CMake. It's like a CMake make file, or the make file is the oldest one, and then we have CMake, and CMake is not bad, I think, but the cool thing on Mason is it has a Python-like style. So it's kind of intuitive. We just code pseudo Python code, and we can just say, at this dependency we have an application, we want to create an executable with these sources. These include directories, dependencies, and additional C++ arguments, and that's it. For example, here we have as arguments, we have a lot of warnings. We say treat warnings as errors, do all this strange stuff and checking. Here we can select if we are compiling for a host machine, for host machine Windows, then we can say add the argument some defines we need for Win32. For the TCP socket implementation, we need the WinSocket32 dynamic link library, and so it's quite convenient and cool. So Python lib Python 3 maybe. Okay, runtime dependency Python 3 found. Okay, good enough. So okay, now we have Python 3, fine. So Python 3 is linked. Additionally, for the linking, the location must be specified. Okay, let's see if we have a Python package config here. Python 3 package config, and this thing tells us that we have a C flag, compiler flag, include directory is in user, include Python 3.10. Let's check this out. Here we should find user include Python 3.10, and here we should have a python.h, and now we should be able to include this python.h in our application, and we should be able to link. Nice. It found the the header at least. Useless cast. Oh, what? Holy moly. The compilation is aborted because I activated all the warnings, but I want to keep the warnings. But now it's aborting the compilation because the header file has a useless cast. So let's check this out if we can GCC disable warnings for header, because how to suppress the warnings from library headers. Yeah, include for those using CMake, you modify include and directed to include the symbol. Yeah, suppress the warning. Yes, Mason, I understand. We have the possibility in Mason to tell we can say you may try to include library headers using iSystem instead of I. This will make them system headers, and GCC won't report warnings for them. Maybe we are lucky. If we say argument a system include is user include Python 3.10. Maybe we are lucky if we no. Did it even work? iSystem include Python 3. That's strange. Why this tick? There is a tick at this point. That's strange. This tick is strange. Yes, because I'm stupid. That's the reason. Oh, it worked. See, we can tell Mason, if we tell the compiler that this is a directory, an include directory which contains system includes, then it's excluding the whole directory from the warnings, because we want to keep all the warnings for our application, because we want to have a high quality application. So that's fine. Okay, so we can include this Python header. That's cool. Fine, happy. And we should be able to include some Qt header and be happy as well. So include Python voice. Yeah, that's correct as well. Let's try this as well. Maybe I just fucked up this part, because I think you're right, neckforcer. This should be used. In this case, no. So, but nevertheless, you're right. That's the way how you do it. We should use these things, not Okay, so now let's include Qt. Include calculate the form. No, I want to include Qt UI tools. Qt for beginners. That's for me. Qt core, a base level that provides containers, much more. Qt GUI, a tool on desktop that provides a lot of graphical components to design. So we need this thing. We have Qt core, and can we use Qt? So we included Qt core, but do we also have Qt GUI? Qt GUI found. Yes, nice. Okay, so that's cool. And now we want to include something. A Qt application. Yeah, let's include Qt application. Whatever. Let's try this. No such file or directory. Oh yes. Do we have find Qt something? Oh yes. Linux U in include Qt6, Qt app. We have installed the development files, hopefully. We have installed the base dev. Is base dev enough? apt cache search Qt6. Qt6 GUI dev. Is there some GUI dev? lib Qt6 GUI 6, the GUI module, but no dev version. Charts dev development core. Why do we have a charts 6 dev but no grep development? So that's everything we can install. I think that's enough we have to do. Wayland, do we have Wayland? Do we need Wayland files? I don't think so, hopefully. Okay, whatever. Q application. Maybe this is somewhere else. User. Find. Oh, Qt widgets. Include Qt6 widgets. Oh, that looks nice. That looks quite nice. Include. Include, yes, but library. Do we have package config? Qt app. It seems that we don't have. Yeah. Okay, then let's try something. Arguments, yep, then user include stuff. Qt requires a C. Oh, come on. C++, yeah, nice, okay. Expected unqualified ID before. C++, at least one argument. What? 11? Why 11? GCC STD standard. What standard can we use? Come on. C++ should be. Is this case sensitive? Oh, did you mean C++? Oh, no. Okay, unrecognized command line option. Did you mean yes? I meant 17. Yeah, fine. ISO requires at least one argument. Invariant make. That's the pipe. Damn it. Yes. Oh no. Yes. Do we have another standard? Damn it. Yep. That's because we are using the GNU standard. Oh no. Oh, okay, we still have this error. Okay, that's fine. Okay, then it's cool. Okay, then I'm happy. Phew. So, but error unexpected fine meaning p-type slots object age unexpected qualifier ID. What? I don't understand what is happening. Python must be included the first. Python. Now, anytime when I do it makes it unbuildable. Why is that? Not dissolvable Python doesn't just Python. I figured it out that when I include mine as first file before Qt includes, it works. No way. What? Okay. I'm happy that I found this entry, and thanks for the poster, Petre. Thanks. Yeah. Isn't this clear to you, Neckforcer? That's easy. Totally. Totally understandable. Yeah, the order of inclusion matters. It seems. Yeah, okay, whatever. So it's compiling, and we have met these two requirements. So very cool. We just need to add the dependency Qt6 core, Qt6 GUI, and Python 3. As long as you know what you do, everything is fine. I'm happy that it's not colliding with the GNU standard, because I'm using the GNU standard. So let's just try to start the application. It's still starting. Let's see if we can connect to the process view. Still, yep, everything is fine. So we can connect to the application. It's running and everything is up and fine. Okay, cool. Nice. Wow, that's quite important. Audio was mathematics, yep, simulation. Literature, okay, that's fine. Simulation. Filtering, simulation, yes. Let's do this. Oh, free. And here, and tap. Yep. And here. Then we have a literature for a list for this thing. Here, tap. And then voice panel must be included first. Nobody knows. Stack Overflow, of course. Okay, fine. Okay, nice. So, next step. On Linux, we GNU compiler G++ and C++11. Okay, on Mac with the GNU compiler C++14. Okay. So, but that's the Matplotlib, and we want this thing. So let's try to. Let's try to do these two things. Just to test. Just for testing. Okay, we have included everything we need. We have to install this thing, yeah. Okay. Okay, so on our main, let's just make a shortcut just for testing. Let's include, I just want to see if this is working, app, and then app execution. Okay, undefined reference to yes, because okay. Undefined reference. The application, yeah, fine. And the tutorial is fully updated, so you must modify change to yes, and the Qt widgets. Yes, we need, in case in the following line, yes, we have to provide an L, but I think we need, the L is included already, I guess. So we have here we have the SO files, VL. No, that's linker as needed. Include. The dependency should be met with this. Let's see if we need widgets. Is this even in library? Oh yes. Oh yes. Qt widgets found, yes. So we just needed the Q widgets as well. Okay, so do we have an application is running somehow? Okay, it seems at least. Qt for beginners, yeah, nice. Wiki Qt.io, Qt for beginners. So actually it seems that the application is running. Let's check something else, because if this thing is running, we shouldn't be able to connect. Yeah, we are not able to connect because we have a shortcut of the rest of the system. So this seems to be working somehow. Okay. Qt for beginners, nice. So undefined reference, just add the widgets stuff. Okay. Our first window. Okay. Create Qt GUI, name of blah blah blah. Qt plus widgets. Qt core GUI. If greater than major version. At first we just needed to add the core and the GUI, and now since major version 4 we have to add the widgets as well. Okay, fine. First file, blah blah blah. Yes, if you use Qt wizards, this is done automatically. The minimal source code for Qt application is very important and takes care of the loop. The event loop. The event loop is a loop. Nice. Okay. Ooh, nice. Look. Now we want to have a button. We want to have a button. And then we create this button with hello world. And this, here we see the show command. I was missing the show command, because now we have to, what? Button show. Why button show? I thought app.show. Okay. Button dot show. Oh, nice. Hello world. Look at this fine button. Button is main window. What? Okay, yes. Oh, okay. Now, yeah, I understand. Yep, more or less. Fancy. We create an application, and somehow this application must know that a button exists because the button is showing, and then the application is somehow processing events and redirecting it to the button. Okay. Nice. So actually that's quite fine already. Push button. Okay, now we can set the tooltip text. Yeah. Properties. So actually this is quite fine. But now we have the problem that this is blocking the entire application, and that's bad. I hope there is a non-blocking version of this exec. Otherwise it gets nasty. Oh yes, come on, please do it like that, please. Okay, so that's so important. That's so important. So we have yeah. We include the whole stuff in the header file, and then we have a Q application Qt and app Qt. Then we should initialize this thing, hopefully. We remove this code from here, Qt application. We have a push button here. We want to create this push button. Let's say Qt application app. Now Qt app button. Oh, come on. Whoa. Sometimes it's hard to decide which version we want to use. So we initialize the button, default constructor. Hopefully this is working or not. Hello world. No, actually I want to use this default constructor and set the button here. Set geometry button. Oh, this is a pointer. Okay, that's a pointer. Yes, so a very important thing to notice, because one advantage of the whole processing system is that everything we write here is on the heap already. So we don't have to use a memory allocation like new or malloc most of the time, because the lifetime of the data is the same as the lifetime of the process. And that's very important and convenient, because now everything we write here is like writing new, but with the advantage that the process is tracked. So we see in the process tree that the process exists, it's in the structure, and we cannot leak any data, because if we create multiple processes, then we see this in the tree structure, and that's very cool. That's very cool. So let's set the text. Can we set the label or something? Button, cube button. Do we have a push button? This is a push button, and do we have a function that is called like set text or something? Set label, set text. Oh yes, come on. Set text, hello text. So that's fine. And then we go to, that's the initialization and mstate. Then we move to state main, and here we say just Qt application process events, because this is the process function and we process the events. Okay, that's cool. Main, we can remove this, and we should say button show. Yes, if this is working, then we are so happy. If I remove a button, pointer gets destroyed automatically by Qt design. Yes, Yes, but I don't know in which environment. At which, when does it, at which point can it be destroyed? Because somehow you have to clean up Qt. At some point we have to Qt app. Yeah, but somehow we should be able to, if we have process events, then somehow we have to destroy the application. Otherwise, because if we create a new push button, okay, I don't get it fully, but maybe I will be smarter in a couple of minutes. Okay, so hopefully this is compiling. No matching function to call Qt application destructor. Can we say argument count 1 app? This is just because of the default constructor. No matching function called to Qt application. I'm stupid. We just have to create the same here. The default constructor in this case must be in copy constructor. In the copy constructor we have this is window parent will destroy button child. This is window parent. This is window parent. Yes. Okay. Okay, that's interesting. That's interesting. I have to read this thing. Now I'm confused because this thing. What is it telling me? In copy constructor, in new button line creation. Okay, in this example, new. So what is this thing telling me? Get displayed. Okay, fine. How is compiled? Make file is generated using Qt build make. Nice. But here, why is it using new suddenly? Parenting system. Parenting system. Yes, the parenting system. Okay, okay. Now, thank you, Neckwasser. Now I understand. We have an application, then we have a widget, set fixed size, and then we have a window. Set geometry. Okay, then okay, and then we have window show and okay. New push button. I think you will need it for sliders. Yes, we need for the sliders, and this means I need. Yes, yeah, okay. whatever. I say I remove this and I say it's a pointer. Hopefully this is working. MP app MP button and then null. So we say in the start is new. Can we say new application at this point? Q application. Does this make sense? Does it make sense? No. So you know Qt. That's kind of cool. But the Qt application may not be a pointer, but the button can be a pointer and should be a pointer. Is that right? And we have a widget window. I forget. Okay. MP window. So we and pointer here. So one moment. We will figure it out. Just a moment. So null. But Qt application shouldn't be a pointer. Okay, that's fine. The button. But the button will be. We have a in the start. We have a Q widget. Nope. Okay, the Q widget isn't a pointer either. So window. Okay, let's keep it simple for one moment. Okay, so just application, mQt application. We want to initialize the application and we need a default constructor, I guess, in any case. So mappqt. So this is where we left. Okay, and it says in copy constructor. That's the copy constructor. Fine. No matching function call to call. I guess there is no constructor. There is no Q application class. We always need this pattern. So arc, what's arc? Argument count, yeah. We need an argument count and stuff. Ooh. Can we do this? Cannot bind non-const value reference to type int of an error value. Yep, nice. Oh yeah. Yes, okay. Py animating. Fine. Okay. You get everything you need. So we give this thing an integer, argument count. We just have to be crazy, then everything is working. Jarban argument values, and here we say, is this possible? I don't know. So I don't think this is working. I forgot how to code. I forgot how to code C++. Forbids flexible array member. Yeah. So then you get an unflexible array. Oh yes, it compiled. What happens if we remove this line? Okay, actually this is not working. So okay, fine. It compiled, and now we try to create a window. But the window is a fixed member. Fine. Now we have a window, and this window should be initialized, hopefully. Oh yes, yeah, it's one nice. Okay, next step. Now we have a button, but this button is a pointer actually. Fine. And we create this button by saying MP button is new Q button hello text, and then we say the reference M window is the parent. If not MP button, very important, return proc error log -1 could not create button. Yeah, button. Okay, so here we say we say set fixed size. Okay, let's do it step by step. Window dot set fixed size 150. Q push button. Oh, thanks. Q push button. Thank you very much. Okay. Now I'm curious. Hopefully it's working. Pointer. Button. Set geometry. Oh yes. MP button. Set geometry. And now we don't say button show, but window dot show, because it's the parent object. And then we just process the events. Whoa. Oh, look at that. And now we have this fine application. And then we should be able to, yes, and now we are able to connect to the entire rest of the system. Oh, nice. So now I want to see what is happening if I, damn, that front-end engineering is incredible. Thanks, I'm so happy. That's so cool. So because now we have a GUI, and we have a very, very powerful system. We can do everything. That's so nice. That's so nice. Wow, cool. I want to check. This phi animating process should check in the main state. We are checking now non-blocking, very important. This is a cooperative system. This means every process is must not block at any point, because the whole tree is ticked every time, every some milliseconds. Then the system sleeps, and then everything gets ticked again. But if something is blocking in the green area, then the whole stuff is blocked. If we have a blue process, then this process is running in a new thread. The entire subtree which is connected to this process is running in a new thread. So if a process is blocking, then the entire tree, which is the entire subtree, which is connected to a certain thread, is blocking. So I'm so happy that this function is existing, because now we are able to process the events by our own system. So the exec function is not ideal. I want to see if this function gives us somehow the information if I closed the user interface, because now I have this window. This window is cool and fine, but if I press X, I want this process to shut down as well. So this process should, in the main, see that the application is closed. Active window returns process events. So the okay, we have a void here. Flags all events. Nice. Core application quit. Asks the application to quit. The request may be ignored if the application prevents the quit. For example, clicked thread safe. Okay, at some point we need to say core application. This is important. This is important. Yes, this is important. I think so. Nevertheless, in any case, we have to implement a shutdown function, success shutdown, because in any case we want to make a clear shutdown. And as soon as the process return positive, if a process has to clean up something, then we have to use the shutdown function. And the shutdown function just makes a Q application quit. And I think this is the thing we need to clean up the Qt stuff. So now we want to check. Now we want to check if this window is still visible. Qt check if window is closed. I don't know if a Q widget is closed. Q widget is visible. How to do whether the widget is visible? Yeah, let's see, maybe. There is a panel also with set attribute quit on close. Wow, that's cool. Set attribute. Yeah, that sounds cool. Yes, it's cool. It's, I guess, on the Qt window. Yes, but I think we have to be careful. Because if we set this attribute and we press X, then it's making a quit on close. It's executing this thing. The first thing that is important to know, I guess this function can still be executed after a quit. What is happening after an automatic quit? Because this process has to be in control somehow, and so we are in the state main. If we press X and then it's making a quit, and it's completely making an automatic shutdown of the Qt stuff, then the first question I have is, and I think it is it safe to execute this function? Yes, but then we I think this is not possible anymore, because OK is equal to is visible, and if OK, then break, otherwise return positive. So I want to check if the the M window dot is visible. Oh yeah, I don't know if this is possible. Yeah, okay, let's just test. We can crash the M window dot set attribute Qt quit on close. Then we make positive, and then we try to again quit. Let's see what's happening now. Here we say proc inflog window isn't visible anymore. Quitting Qt application, and then we will see if we have any crash at any point. Okay, so yes, makes sense. Oh, come on. No, come on. Pool, okay. Window isn't visible anymore. Quitting Qt application. Oh, that was easy. Yeah, but try minimize to hide the visibility. Minimize. Okay, so let's see. Now we have a pie animating, and if we close the window, then as you can see, the process finished. Cool, the process finished. But I think I'm not sure if this quitting is still active. What is happening? I guess we can omit this attribute set. Let's check, because I think it's detected anyways. Yes, as you can see, it's detected anyways. Anyway, so we don't need this attribute in this case, because the cool thing is you are quitting Qt application. A window isn't visible anymore. Shutting down. Okay, Qt window. Qt window isn't visible anymore, and as you can see, this the process is has a plus on the left side. This means the process is finished. The difference between a function and a process is that a process must be cleaned up, but on the other side, in general, we don't want to do anything else. If we lost the user interface, then we don't want to do anything else. So we say in the root in the application main process, we check in the main, we say success is equal to our animation process success. If success is equal to pending, then break. Otherwise we say return positive. Here we need the success, and then that's fine. What is happening in the supervising process? It's yes, here as well. Yes. Positive, pending. Yeah, I guess we need the same here. Okay, so we say processing pointer mp app supervising app start. Let's call it mp viso. mp viso. Debug start. Oh yes, we don't need debug start. Yes, let's clean up a little bit. So like this, we have a debugger. Oh, what is happening? Ah, fuck. Oh, what? Oh, look. So now, relax. Relax. Okay, so app start. We can remove app start. Very important. We have to initialize every pointer. Viso null. So mp viso is created here. If not mp viso, then could not create process. Fine. Return. Otherwise mp viso, nice, main, and here we say success is equal to mp viso success. If success is equal to pending, then break. Otherwise return positive. Oh, positive. Come on. Ja. Missing. Oh, thanks. Oh, thank you. Nice. Okay, so now the application should make a complete shutdown as soon as we remove connection closed. So as you can see, the last thing we have seen, if this is positive, then this is positive, and if this is positive, then this is positive. So we can open and close the application. Oh, and everything is done. But connection closed after earlier was earlier, right? The connection was closed. So this is a monitoring. So the data of the process tree is sent cyclically every, I don't know, 500 milliseconds. And if it happens that we get the latest information, then we see this stuff. But the connection is closed as soon as the debugging process is closed, and we don't see the debugging process because in the supervising process we deactivate the visibility of the debugging process. Actually, we have another process which is running, that is the debugging process. And as you can see, here we have a lot of stuff system debugging, we have 3 listening processes, 3 servers for 3 channels, and it gets updated all the time. But here we see the connection, the TCP connection of the process 3 itself, and if the Pi animating process is shutting down, then the visualizing is shutting down, but not the debugging process. Okay, I understand what you want to say. I didn't get the question. I don't think that it was it died earlier because we saw here a plus and here a plus, but let's just test it. Here we have a running connection, and if we close, then again the last thing we see is that every process was shutting down. I was dead before you ran the latest code. Okay, but now as we can see, we closed the application and then the connection was closed in a clean shutdown. I'm sorry, new here. Hi, what are we doing? Hi, slime swallower. We are creating a cool application, a very cool application actually. I'm so happy. We have a Python tool in which we can create very easily a minimalistic simulation surface. And on the left side we can parameterize the simulation, and on the right side it gets updated immediately. And I want to say this is written in Python, and it's quite cool, but we want the same thing in C++. Because I'm more likely to create a C++ application in the future, and we are quite far already because we installed the dependencies and configured the dependencies. We have included everything we need, the Qt application and the Python, and now we have created a Hello World widget, a Hello World window. And besides that, we have the rest of our system, which is quite cool as well, because we have a lot of stuff. We have a command interface, we have a thread pool in it. If we need it, actually we don't need to use it. We can if we want. We have a cool logging system. Yes, and that's it. And if we close the user interface, then the whole system is shut down. Yes, the system we want to create is, and that's very cool. You can find the repo here. If you can give me a star, I would be so happy. But you can find this is the core. This is the core file we are using in any project we are creating. This is the base class for everything. This is the base class for everything. So that's the main class, and it's this is our star here, and this audio processing repo here, we will add all the code for today. And the thing we want to achieve is we want to build this structure. And at the moment we are working on the PC simulation, and especially on the visualizing part. So if we want to create the system, then we just have to implement this rectangle, this, this, and we can check as soon as we are finished, and then that's quite cool. And this picture is created very easily. If you don't know it, with you should definitely check it out with plant.uml. So online you can just say a plant.uml live. Then you have the plant text UML editor, and this picture is just a text, and you can change the text. For example, a PC simulating foo, and then press Alt and Enter, and then you have a new picture. And with this tool you can rapidly create a documentation for your system, because I think it's all you need to know. Which processes need to be implemented, what process is doing what. For example, we have a signal generating process. This process is creating samples. In the ESP32 we have a TCP server, which is getting the samples, collecting the samples and sending it to the input samples. Then we have a filtering process and so on. And yeah, that's it. Simulating. I like the oh yeah. Then if you like the ADC DMA part, then you will be excited when we implement the simped part. So we make quite a complex system, and so we are quite greedy, because we want to have the full fancy stuff, but I think we will get there. Yeah, it's cool. It's really cool, because we are moving forward quite fast, I think. Actually, I'm quite stupid. I don't know what I'm doing with the Qt stuff, but let's see. This code, I wrote this code a long time ago, so I don't know what I'm doing. So I know that I have created this thing, but I can't remember. Do we see? No, that's a wrong date. That's a wrong date. So this file is quite old. But yeah, I'm also working with Qt right now. Qt5. Oh, okay, cool. Yeah, Qt is absolutely nice. So at first we should, let's try to make the base structure of. Let's copy the base structure. Yeah, the Qt is so powerful. That's amazing. So we have to check the license. Usually I have the GPL license, but I'm not sure if I'm allowed to do this because of the includes of Python and Q application. So we have to check this out. If you use this process, then you have special license requirements, so we have to be careful. And that's the reason why I want to isolate all the code, which is you got my stuff at the Git. Oh, really? Oh, thank you so much. That's actually helping a lot, because it seems that nobody cares about about the repo, but actually I'm using this class since 2018, and it's a finished code, and it makes me so happy every day, because it gives me a clean structure, and it's helping me. So why do you need to include Python? Yeah, that's motivation. That's some motivation. I need to include Python because I want to use Matplotlib. The Python version has two parts. The first part is the surface itself, and the surface itself contains two parts. The left side is some widgets, and the right side is an empty canvas drawing area, and the empty drawing area is bound to a Matplotlib handle somehow, and I'm plotting with Matplotlib in Python, and with Matplotlib it's like MATLAB, and as you can see, it's so powerful, and that's the reason why I want to use Matplotlib, because you can move the stuff around, and yep, that's quite amazing. And then we can create a button, or yes, we will create the button. We want to have everything. And I want to be able to make a live signal and then get the live signal from the ESP simulation, or we are able to this part can be compiled on the PC. If it's compiled on the PC, then this part is missing because we don't have actual hardware. But then we can just connect to the virtual ESP32 and then send samples in it, and then have a test the filter and then read the output samples. And if it's compiled for ESP32, then the whole thing is included with the hardware modules, and also with the simulation interacting. So still, if we have the hardware, if we have the software on the hardware itself, on the ESP32, then we have the hardware stuff, and we get the samples from the ADC DMA combination, and then this path is active. But on the other side, we are also able to still connect the simulation to the ESP32. So the selecting process usually takes the samples from here, from the hardware, but if it recognizes a stream from the simulation, then this has a higher priority, and this path gets activated and output on both parts, on the DAC as well as the simulation. Just IDF. I'm not using Arduino because I'm not a fan of Arduino. It's cool. It's cool. Yes, it's quite cool. By the way, you can connect to the ESP32 already. Slime Swallower. If you have Telnet, then just type Naegulus testing USTU 3000, and then you see the processes which are running at the ESP at the moment. And then you can, and this is the log interface, and this is the command interface. I think the log interface isn't doing that much. But here you see that we have an ESP Wi-Fi connecting. That's not contained, this process is not contained in the simulation. I skipped this process at this picture because it's not important, but the ESP32 is connected through Wi-Fi. Again, yeah. So, but as you can see, here we see the ESP Wi-Fi connecting, and okay, this is the simulation application. That's a completely different application. It's not the virtual ESP. So So, and that's what we are doing here. And thank you very much for the star. It makes me quite happy. So, can I use UUI? We have beginners. Yeah, that's a cool thing. For beginners, yes, nice. We have an application and we have the basic stuff. Okay, nice. So let's try to copy the Python stuff, the Python code to okay. Set minimum size. Okay. We have a window. It seems that we have a yes, we make window resize. Window resize. Q window. What is this? This is a widget. Q window. But widget is just the window is just a widget. The window is just a widget. Okay. So I should use the simp buffer thingy to write OOB and take over the ESP out of buffer. Yes, you can. Sure, yeah. You can if you want. This command interface was not meant to be safe in this case. So you can take over the ESP32 actually. Sure, if you want, no problem. Telnet 32 help, and here we can print. Yeah, we can print the buffer, and here we see the buffer, and the buffer is located. The buffer is located on the heap. It's located on the heap, but you can completely destroy. I think you can destroy the buffer because this, yeah, with this command, because this command has an offset, and with the offset you can go out of bounds. Yeah. So, and that's quite more or less intended, because security wasn't an issue at the moment. So okay, yeah, we have to use a resize. We should core application. We should add some Q core application class. The core application class. Let's just add some literature, because I will need it for later anyway. So docs. Okay, that's a different page. Interesting. Q core application class. So for every application. Yeah, but heap exploitation is annoying, so don't worry. yeah, heap I know. If you want, you can try to exploit another thing. We have telnet, Naigulus USTO. That's our gaming server. This gaming server is also created with the base class, processing class, and in this gaming server you can create the game, and we can play Connect 4, for example. It's a multiplayer game. You can connect, and then we can create a server, and then someone is winning. And it has an SSH server process included as well. So maybe the encryption, it should be quite stable, but it's running for 3 months already, with all the bots connecting all the time, so it's quite cool. So that's actually that's the main project of the stream, but that's the side project we are working on. Never ever work on the main project, because working on the main project isn't cool. Just work on side projects. So I cannot connect to it for some reason. Interesting. Interesting. You cannot connect to it. What's the port? Maybe wrong default port or something. I don't think so. One moment, log catching. I want to. This is from December, 5th December. Okay, yeah, that's fine. The logs. Why don't I have a script for this? Come on. I don't have a script for. I want to send a user. I want to send a user signal. The PS. I have created an application which is called log catching, and this log catching application has a FIFO, and this FIFO is filled all the time. And if I send a user signal to this application, then PS, then oh yes, so that's the gaming server. This is the administration server. Kill, yes, exactly. Kill user 1. The left or the right one? PID in the left one. Oh, using the IP worked. What? Oh, okay. What? Why? Huh? Okay, then just use the telnet. Nice. Then use the IP, telnet and IP. Let's test it. Telnet, IP. What? Huh? So this isn't working for me. But for me is trying. Yes, that's what. That's cool. That's cool. Yeah, die das in Okay, let's see. What is my IP? Port checker. Open port check tool. You should be using. No, this is complete. It's my IP address. This should be the IP address. Yes, this should be the IP address. Telnet, and this IP should work. You are connecting not to the gaming server, but to the to my PC at home. So this is a different server, and you should be able to connect. But if you are not able to connect, then we can check why. Kill user 1. still doesn't work. Yeah. Let's see. Copy. And now we should have, hopefully, now we have a user entry log. A log which is created on this timestamp. The TGS, the gaming server, with this hash and triggered by the user, by me. And then we have less minus r. Let's remove all the logs. And then we should have one user log. Yeah, nice. Less minus 7. So as you can see here, we have a connection. Weak play 91. That's, for example, that's a bot connecting to the server. It has a user agent. Or that's interesting. If someone is trying to enter the server with root access, then I'm printing the used password and all the interesting stuff. And it seems that this bot is using a Paramico SSH client. I don't know what that is. Paramico, wait, Paramico is a pure Python. That's expected, that these bots are written in some Python stuff. So it's some minimalistic Python thing. Okay, so maybe we see the reason why you are not unknown do option. Could not get key. That's the reason why we have a peer at this thing and unknown do option. Okay, unknown do option, nice. Telnet filtering, yeah, then we just have to accept this key. One moment, should be fixed hopefully quite fast. Core common. This project has already quite a lot of lines, 30,000 lines. Yes, but you should, you can use a netcut, but it will not be working. This is not working. Okay, so now I try to build this thing. Build native Ninja, but I can connect at least. You can connect, yes, but it's not working because we need the telnet protocol, because this thing needs your terminal in a raw mode, and the raw mode can only be set with the telnet protocol. Let's see if we can try. We will do the following. We will start this thing. Not QoS. I will check the ports. The ports for the ESP32 3000 are okay. You can connect telnet on the testing, I guess. Okay, so let's start the server locally here, and TGS will help verbosity 3, port telnet is equal to 4000, and port SSH is equal to 4001. And then we want to, yes, creating host key. Yeah, nice. Okay, fine. And then we should be able to connect to telnet naigulus testing usto. Yes, that's fine. Oh, we should increase the verbosity. Yes, perfect. Now we have a visitor. Okay, fine. So we can now you should be able to connect to this thing. At least you can try, and then we should see. Then we should see that we have an error. Yeah, see unknown option, and we will fix this here now in the telnet filtering. We say unknown option. What? Unknown option do. Uh, 16. Okay. We can ignore. Do we have an ignore macro somewhere? Ignore. Let's say ignore. Do we have ignoring? Yeah. Let's just test it. Unknown do option, and we say just for testing. Key is equal to 29. Let's make a break. So as you can see, we always have the same structure in our processes. 26. 20. If the key is 26, then we ignore this thing. Ninja. And can you try it again? Maybe there is another option which is critical, but yes, as you see, FF, we have to ignore FF as well. Okay, nice. Can you retry? FB, okay. How many? So you implemented the whole telnet stack. As you can see, no. I just used the minimal options. I just passed the minimal options. The SSH server is also not implementing every cryptographic algorithm. But just the most important ones. So if you have a client, can you tell me which client you're using? Because I tested this thing with Putty and with Telnet. So actually, if you're using Windows, this should work. Can you try again? So now I ignore these options. FD. Okay, FD. I can check later what these options mean. Okay. We got 26 FF, FP, FD. Okay, adding visitor. It seems that you were able to enter the but I'm not can you navigate? Do you see this? Can you press C and then see a create game frame? So it's working. So try to create a server with a C and then press enter. Oh, beat this connector. It's yeah. Then you can press 1. You can press 1. And if you now press enter, then oh, cool. and then now we can play. So it's counting down, and then we can play. And slime swallower, you can move around with the arrow keys theoretically. Yes, nice, perfect. And then oh, nice. And if you want, you can connect as a spectator. Now, because the match is running already, you should be able to connect as a spectator. And then you should see the game we are playing. But I'm not that good, because I drank wine already. So this is the main project, which should yeah, nice. If when you are on the server list, then you have to press R for refresh. Otherwise you will not see the server. Oh, that's the, oh, damn it. If you press R, can't see the server. Yeah, press R. Refresh didn't work. Neck faster, that's good. Are not working. Okay. That's are not working. Oh, let's. Oh, I'm confused. Ooh. Let's try to. Can we connect? R is not working. That's oh no. I lost anyway. So, but that's strange. Because actually you should be able to. Oh, nice! You won. That's strange, because if I connect to the server, now I see the BTs, and if I connect here, telnet localhost for 4000, then we have another instance. You could have won the turn before, though. Oh, really? Didn't know there was a time limit, so I misdropped it. Yes. So I still have to improve the gaming experience, but we should be able to create we should be able to create the game. And now if I press R, I see the new game, and then I can connect to it theoretically. But now I'm not sure if weird, yeah. Type helm frame. Yeah. Okay, so it's still in progress. But thanks for testing. Can you tell me which telnet client you were using? Are you on Windows or Linux? I guess Qt. Or Qt. Okay, that's interesting. Linux. Win11 Linux. Okay. Telnet test. Windows 11 Qt and Linux. Just Linux? Okay. Yeah. Telnet GNU init. Oh, thank you. Okay, and the other one is Qt. Can you check which version of Qt? Android OpenBox last time. Android OpenBox. Okay, I must say Android OpenBox. So to be fair, I didn't test it, so the stuff that is not tested is not supported at the moment because the telnet is just very basic. Only the very basic stuff of the telnet protocol has been implemented. So I'm currently only supporting Linux telnet and PuTTY, but I will download the Qt and stuff, and then I will add the stuff. It's just adding some small changes. Oh, perfect. Thank you. Thank you very much. So I will check this out and then we will fix this. Yes. So interesting. Let's check which version I am using. Telnet version. I was using Ubuntu at first. Now I'm using Debian. It shouldn't be that different. I think I'm also using the GNU utils. But okay. So, but you both had the same problem with the telnet. I have to check. The telnet has version. I used -- version. I have the BSD version. That's different. BSD is another one. Okay. And every client is sending different stuff. Yeah, mine has that. Yours doesn't apparently. So okay. Never mind. Just to show you, my SSH client, for example, is supported. If I press SSH at Naegulus USTO, then no, thank you. Actually, thank you very much, because I want to support, of course, as many clients as possible, and so this will be a task for next time. That's very important for me. Thank you very much. And if I use SSH, then the whole communication is encrypted. As you can see, when I'm using telnet, try to, yeah, because the telnet thing is for guests, and if you want to have an account, then you have to create an account, but it's not open if you have to pay a small amount to make it open, but you can make create at Naegulus USTO if you this. Because it's a special SSH implementation, I have this special keyword. If you press SSH create Naegulus USTO, then you can make an account creation. And then it's your telling you stuff, and then you have to type an email, and then for example, and then repeat it. I'm so proud of the text box logic, I can't tell you how much. And if I press enter, then I get a verification email, and then, yeah, I have to type the verification code in it, and then it gets activated, more or less. Then it gets created, and then if this server is receiving, it's connecting to the PayPal API, and if the server detects an income from your, it's supposed to say 1 text, 2 text, 3 text. What? Yes. Yes, you see, it is supposed to, because I didn't, it's not finished. It's this project is completely alpha, and so it's supposed to do to say that, and the terms of service also are not completed yet, and this is in the resources, I think, registration instructions. Nope. I'm out, boys. Good night. Good night. Oh, good night. Thanks for watching. See you next time. Next time is on Thursday, hopefully. So I will fix this, and hopefully someday, if we finish the audio processing project, then we or maybe we'll switch. Any non-German people still here? That's a good question. If there is nobody non-German, then I could switch to German, theoretically. Oh, the neck is still here. Oh, So, but now we have to switch back to the audio processing thing, because I just want to try the window resize function. I'm from Chile. Hey, cool. Greetings to Chile, and thanks for watching, of course, and thanks for testing. So Paramico, nice, Paramico. Bye, good night. So literature simulation, literature, yes, let's say telnet test, and here we say that's interesting. That's a very interesting thing. The client, the OpenSSH client, which they use to hack me, but they have no success, because we close every connection that is in the slightest way strange. For if the server detects something minimal strange, then it's disconnecting immediately, as you saw earlier. Then it's just disconnecting. So we filter everything strange out, and in your case we had false positives because it's not implemented completely. So nice, that's interesting. That's a very cool client. So that's nice as well. Yes, let's add this thing as well. Ooh, nice. Stack Overflow. Using Qt in non-blocking way, very important. I'm so happy that this was working. Q core application, Q push button. Q core. I wanted to add Q push button. Now I understand. So Q push button. So, but now we have to check for Q widget. Do we have 6.6? Nice. Search for Q widget, and in Q widget class, yeah, nice. Q widget class, we have core application. Next level is the widget. But I think we proved that the processing class is quite able to handle bigger projects and more complex ones if you want to use it. So it's quite cool. So we have the Q widget class, and here we should be able to have a resize function. resize. Yes, QWidget resize. Oh, nice, nice. So this should work actually. Resize, the same as here. That's so cool because it's quite similar. Then we say we want to have a minimum size 400. Hopefully this is working as well. Is this function known here? Set minimum size. Look at that. Then we have a push button. Let's test. Oh, now we have the same size like before. So step by step, we get the stuff we want. Oh, if we have this class as C++ version, then then we have a reason to party. So cool, so cool. Oh, then I can drop the whole Python thing. Wow, nice. Okay, so now I want to have a Qt layout. So let's check. I'm using the VI plugin, the Vimium plugin. I can recommend it. Without it, I'm not able to browse the internet anymore. If I don't have this thing installed, I'm like the complete noob. I can't even do anything without it. So Q layout class. So QWidget, and then the next step is to have a Q layout, vertical layout. Why a vertical layout? Vertical box layout. That's strange. I thought the first thing. Yeah, vertical box layout. Yeah, Q vertical box layout. Vertical box layout. 3 sliders. Oh, and then layout. We should not copy from here. 3 sliders. So yes. The next step is I want to see this grid layout. Whoa, options. Okay, that's the Q layout, and then we have grid layout. Yes, I understand. This is we add a layout to what? What is this? That's a grid layout. We get a new grid layout. Yeah. Step by step. I understand. Because now we need this, and we press enter, and this is, yep, very fine, perfect. And we have a box layout, then we have a grid layout. Let's say grid layout is first. Doc Qt.io. So step by step. I want to see at least the layout, and then the sliders would be cool. But as you can see, this base class is just creating the minimum stuff, and the minimum stuff is just it's divided into 2 parts. The Python thing is divided into 2 parts because it's maximum convenient. Because the Python thing has this physics animating class is the base class, and it's doing the stuff we don't want to deal with in general. The main thing, the thing you want to write is this one, for example, and this one is able to just derive from phi animating if we derive from phi animating, then we get even less. We just get an empty screen with just the layout, but without the sliders. And at this point we can add a custom slider. So for every simulation project we are creating, we just say, in this case we need a slider with a time offset and the frequency and the phi, and in the next simulation we have different sliders and we are testing something completely different. We can make a completely custom subplot, so we can use this canvas in any way we want. The base class phi animating is just creating the layout and the canvas, nothing more. And then we can add, for the special simulation we want to do, we have a title, then we have sliders, and then we have a certain plot. We will make this in a similar way. At first we will try to just add the sliders, hard coding the sliders, but later on we want to derive in a similar way. Okay, so step by step. I had a shortcut in my head, in my brain. Non-blocking way. Oh, I'm so happy that this is working. This is so perfect. Okay. Sorry, just give me 1 second. I want to make a new grid layout. So I need this one. This is the layout at this. We will need a pointer for this. So we say we have a widget window, and now we need a grid layout pointer mp grid button null. Perfect. Now after the window we create the grid layout with new grid layout, hopefully like that. Let's just compile and try to compile. Does not name it type. I guess we have to include the grid layout somehow. Include grid layout. Yeah. This is temp, I think. Oh, maybe not. Oh, okay, it's fine. Closing. Oh, let's do. Now we have another. We have two sources of closing requests. The first request is if I press here, then the application should close. If I press Control C here, then we have another source, and this should work as well. And it does, because the whole application gets cleaned up as soon as I request a shutdown. In the main I have an application. No, yes, at the moment. You're good. You're a good guy. Or are you? Never mind. In this case, we have a memory leak. Yep, absolutely. Of course, yeah. So this structure does not is not able to fix memory leaks in this case. So it's not able to prevent you from making memory leaks. It just reduces the possibility of creating memory leaks, because usually you don't need the new operator. Maybe yes, maybe we can add the stuff here, but I don't think so. But as long as we connect all the stuff together, then it's fine again, hopefully. Okay, add layout. Now we have a grid layout. So, but we have to check if not mp grid, then hoo. But that's dangerous, grid, because if still this is able to produce a memory leak, because we have to connect the outer layout. Central widget, the central widget, central widget. What? Set central widget. What kind of function is this? Is this a Qt? Main window container. Okay. Q main window. Okay. Yeah, okay. What? Nice. Nice. So, at first, should we do it like that? M window. Is this a pointer? Let's try to compile this thing. Main window. Q main window. Maybe we have to include this thing. Cannot call member without object. But core application. Unfortunately, M window set central. Central widget. Oh, okay, like this. But then I wonder how to. Yes, maybe. Yeah. But possible. Main window. It's strange. Self. What is self? UI base create self. Because I am a main window. This is because I am. Yeah. I'm derived from main window. And that's the reason why I can say just like this, because I would need to derive from whatever. Base class should be explicitly initialized in the copy constructor. Yeah. Should be explicitly. Nice. And then I should do like that. Or must construct before a Q widget. Oh, nice. Looks better. Looks better, actually. Must construct a Q application before a Q widget. Okay, Q widget, M window. But isn't the M window already a main window? It's a widget. It's a widget. I don't know actually. Maybe we don't need it. But we can do this later. But we should add it to the documentation main window. Okay. So let's at first the reason why I'm asking because if we create with new a grid layout and if we have an error here, then we have a memory leak. So here we have to do a link already. So we have to make the link immediately and create the links immediately. Very likely wrong written. Immediately. Okay, so because as soon as we make a shutdown, a quit, then all the stuff that has been created already must be cleaned up. But later, we have a grid layout. Then we add a layout. So we have created a grid layout, and then we say mp grid. Now then we can make dereferencing, add layout, a special option that is QV box layout, and then we say 0, 0, 1, 1. A non-matching function call to grid layout and into box layout intended. Let's see, grid layout, add layout, pointed to a queue layout. Oh, okay. New. Okay, started at least. So we have a grid layout, and then we add the layout. Yeah, we haven't connected the layout yet. So now we add a widget, a canvas. Oh yeah. Set a layout at the layout. MP layout. Das ja. Okay, whatever. Central widget. Set central widget. Okay. Can we say? This will be. This will be a problem, I guess. M window. Set layout. MP grid. This is a widget. If we does this function have a set layout? Qt set layout. Set layout. Oh yes, it has. Okay, okay, so nice, okay. MP grid, oh yeah. Okay, so we have created we have resized the windows, set minimum size. We have created a grid layout. We add a QV box layout 0011, set column stretch like this. In the column stretch, the left side is one part and the right side is 3 parts. And then we set the layout of the window. And then we say window show. Maybe we have already, we don't see a line here. Okay, maybe that's fine already. So let's try to add a slider. My internet appears to be dying. Guess I will be gone for a bit. Oh, okay. Let's add a widget, a Q-slider widget. Qt horizontal. Ooh. Just for the moment, a Q-slider. We can set. Let's try to make a Q-slider. Slider. SL. Pointer PSL. Oh no, let's try to add this. Let's add the button to the left side, because now we have the button on this side. Set the range. Add widget to the options. What? Why options? Okay, the options. The options is the box layout. Okay, I understand. So we have to say the VBox layout. We have to add the VBox layout. VBox layout pointer MP VBox. The VBox. So we have a grid layout, but first we need a VBox. VBox is new if not VBox could not create VBox. Vertical box. Okay, then we add layout VBox, and this is the stuff we connect the elements to. For example, we have these options, and if we want to add something, then we add this to the widget, to the VBox. So for example, we say MP VBox add widget. We connect. Maybe better to create VBox after layout. Yes, that's very good. MP button. MP grid. If we have, and that's the linking I was talking about, neckwasser, that's cool. We have a grid. We create the grid. If not working, then go out. If we create VBox, yes, we theoretically, somehow we should be able to, the layout, yes, set layout. Where is the set layout? The window, yes, here. I think this is it. We always have to create, and if we were able to create, then immediately link. So the window is here, it's created already. Then we try to create a create. If it did not work, okay, fine, go out. But if it worked, connect it immediately, so it's in the system of Qt. Then try to create the next thing. Then add this thing immediately. Fine. Then create the button, set the stuff, and then add it as soon as possible. Okay, so set geometry. Do we need a set geometry? Do we need this? Oh, look at that. The button has the same width. It has the same width as the parent object. Oh, that's so nice. The only thing we have to do is tell this thing to have, now we need something else. As you can see, it was in the middle, and here we have it on top. That must be some option. That must be some option somewhere. This was not add widget on layout, set layout, fine, set range, two-sided. Okay, we can create a two-sided thing or a one-sided. A slider, horizontal, set option, add widget. There is something that is called a spacing element. There must be some spacing element somewhere. In the initializing part, we say add subplot. Here, no. Do you see? Add stretch. We make a 3 tick, and then we make an initialize, and then we add a stretch. We add a stretch to the options. That means we create the push button, we add the widget. In the initializing part, we create all the, we execute the initialize function. Then maybe just for testing at the moment, just for testing. MPVBox add stretch 1, whatever that means. So now it's on the top. Because we now, this vertical area, we have divided the whole area into two pieces. The left, a vertical divider, left part is 1 part and the right part is 3 parts. And here we have 2 elements inside, one button and then a stretch element, which is moving the button, trying to get as much space as possible and then moving the button up to here. Maybe there is a default in the QVBox layout, maybe there is a default. As you can see, add widget, all the stuff should be created on the on the heap, like Spring pushed the two sides. But it would be interesting. As you can see, this is quite annoying that I have to make an initialize and then make an add stretch. That is quite annoying. I don't want to do this actually. It would be cool if I could say that stacked layout. What's the stacked layout? A stack of where only one widget is visible at the time. You can put it between last slide and the button. Yes, but the problem is that this phi animating should just be the base class. This should be just the base class, but okay. No problem. So I'm so happy for the result today. I can't tell you how much, because it's amazing. It's amazing that we now have. I hopefully the Matplotlib stuff is similar easy. But that's so nice already. It's so nice because it's fast and nice and yeah. Let's say we continue on Thursday, 8 o'clock as always. And thanks for watching. And if you liked the stream, maybe you can be so nice to me. It's not needed, but if you can give me a star, I would appreciate it a lot. Otherwise, we see just see us next Thursday, and thanks for watching.